Welcome to homework.
We're told that we have a wire that has a resistance of 5 ohms is connected to a battery, has an EMF of 2 volts, and has an internal resistance of 1 ohm. So in 2 minutes, how much energy is transferred from chemical form to from chemical form in the battery? All right. So how much we need to basically figure out how much power the battery is producing, and then we know that it's producing that for 2 minutes. So the power. So in this case, we have a battery here, and we have an internal resistance, and then we have, let's see here, another resistor, and then coming through here. And so the power, we have R1, the internal resistance R2, and then here's V. So the power is V times I, but I is V over the total resistance. So the power is V squared over R1 plus R2. So these are in series, so they sum up. And that winds up being 2/3 of a watt. So we're putting out 2/3 of a watt of power from our battery here. And now we do that over 2 minutes. So again, if this power is constant, we have 2/3 times 120 seconds, and that winds up being 80 joules. So 80 joules of power is of chemical energy is converted to electrical energy, and then obviously to heat or whatever. Now let's see here. We asked for what is dissipated as thermal energy in the wire. All right, so we have thermal energy coming out of here, right? Because this resistor. So we want to know how much energy is coming out of this. So we know we know I is V over the R total, which is 1/3 of an amp, and so the power dissipated by this resistor is I squared times its resistance, and its resistance is 5 ohms. I squared is 1/9, so we get 5/9 of a watt. And now again, this is happening over 2 minutes, so we multiply that by 120 seconds, and we get 67 joules. So 67 joules of energy is being dissipated. Um, uh, 67 joules of electrical energy is being converted into thermal energy and dissipated as heat. And then they ask us how much is dissipated as thermal energy in the battery. Well, again, we can say, well, we know what the current is now. It's 1/3 of an amp. What is the resistor, internal resistance in the battery? We know that is 1 ohm, and we know the time. So we get the electrical energy dissipated, converted into thermal energy in the battery is R1 I squared times T. And that's 1 times 1/9 times 120, which winds up being 13 joules. And so we can see here that obviously these two things add up to this thing. So this is the total power that is total energy being converted out of here, and then that is all being dissipated into thermal energy, some through the resistor and some through the battery.